Hello everyone. So today I am here with you with my new video on MSA, which is called Measurement System Analysis. And it's a very good tool to identify whether your measurement system is working good or not, or it is good to work or not, or you can also do the validation of your measurement system using the measurement system analysis. Actually, this topic is a bit lengthy, so that's why I'm making maybe 3 to 4 videos on MSA or the different part of MSA, because I don't want to make a 1 hour or 2 hour video just on MSA. I think that will not make more sense for you as well. So to save your time, I'm making different videos on MSA. So today, this video will talk more about the MSA accuracy part, and then I will make some more videos on MSA precision and gauge R&R part. Gauge R&R part. Okay. So so let's start this MSA then. I have a question for you before starting. You can see there are two processes, process A and process B, right? If you see both the process, the overall variations are looking same. In process A, the overall variation is the sum of the variation coming from the activities in the process, maybe the different tasks or different steps of the process, different inputs of the process, and the variation due to the measurement system. Similarly, B is also having the variation in the activities and variation due to the measurement system. So I have a simple question for all of you. Is this, which process is good? Is it A or B? What do you think? So answer is, if I look at the total variation or total process variation, both the variations are same. So it's very difficult to say which process is good. Okay. I have another question for all of you. Is this, which process is easy to improve? Is it A or B? Think of it, please. Okay, let me tell you the answer. So the answer is, if you see in process A, the measurement system variation is very less, but in the process B, the measurement system variation is more. In the other way, if you see in process A, you have more variation in your activities, in your steps, or in your inputs. But in process B, your inputs, your activities, your steps are very standardized, are very good. The variation in those steps or in those activities are not too much. So by looking at this, you have to improve in the process number B only the measurement system. So if I'm having a measurement system, let's say weighing scale, or if I'm having a measurement system of pH meter, if I'm having a measurement system of vernier caliper, if I'm having a measurement system of maybe some kind of equipment or some kind of tool, so I need to improve that particular measurement system. If I improve this, automatically your overall process variation will improve. So by looking at this, which system is easy to improve? It's B. So let me just conclude in this part. So if you have a process and you can see the measurement system is having a huge variation, so the first thing you have to do is you have to calibrate, or you have to validate, or you have to upgrade your measurement system according to the requirements. Okay, and then go and check your process variations. Maybe your overall process variation is coming just because of the measurement system. So you just validate, calibrate, or upgrade this part, automatically your process variation will improve. So that's why this measurement system analysis is very important. Sometimes very simple steps in the measurement system will improve your overall process variation, right? So let's move on and understand and go to the deep dive of measurement system analysis. Let me tell you a few more facts or few more benefits of measurement system analysis. So MSA helps us, as I mentioned, to validate the measurement system, whether it's good, bad, working fine or not. MSA will held or will be used actually before commencing the data collection, because if you have or if you are going to start the data collection, before that only you have to check whether your measurement system is working good or not. So that's why the MSA study will mostly done before the major phase of DMAC. Okay, so as all of you, we have DMAIC cycle: define, measure, analyze, improve, and control. So MSA will be done before the major phase when you are actually working on the data collection part. Now, sometimes you have the historical data, right? You already have some kind of checklist, some kind of data sheets, or some kind of data already available with you for study. So in that case also, you should definitely validate your measurement system, because you are going to rely on the data. And if your measurement system is not working good, how you can rely on your historical data, right? So that's why the validation of measurement system is really important. So this MSA study will tell us how we can validate our measurement system in different ways. Okay, let's move on. There are two type of MSA, majorly two type of MSA. One is called accuracy, other one is called precision. So what is the difference between accuracy and precision? There are four diagrams you can see, and I've already mentioned clearly what are or what is the difference between accuracy and precision. I hope you know this. So this is bow and arrow, or maybe the gunshot where you have bull's eyes in the center, which is your target, correct? So if you see, there are the observations, or maybe you trying to hit this bull eyes, but what happened? Your observations or your data is coming in this area, which is actually not accurate, not precise. If I see the second diagram or second photograph, it says the data is accurate because it's very near to the target, but it is not precise, right? You see the third figure, it is precise, the data is very close to each other, so that's called precise. So if I need to reach to the office at 8, but I'm every day reaching at 9 past 1 minute, 9 past 2 minute, 1 past 9, 9 3, 9 4. So I'm very close, I'm very precise to 9, but my target is 8, so I'm not accurate. Okay, but if you see the last figure, precise and accurate. So that's why our measurement system should be precise and accurate. But there is a question, or there is a point here. We'll say a measurement system is good when it is precise and accurate, but how much? But how much? So that's why this measurement system analysis will tell how much precise, how much accurate. We'll talk about all these things. Okay, let's move on. Now, accuracy, as I mentioned in my previous slide, so we have measurement system analysis as accuracy and precision. So accuracy is having four parts. Okay, so start with the linearity, stability, resolution, or discrimination, and the last one is bias. I will touch upon this part in this video. And there is also one more thing which is called precision. I will just give you an overview of precision in this video, but in the next video I will go and deep dive on the precision part. That's why I'm saying this MSA is a big topic. So in this video I majorly talk about accuracy and different factors of or different parts of accuracy. Okay, let's move on. So the first thing is called resolution and discrimination. I have three figures in front of you and three questions, and it will definitely guide you, it will definitely help you to understand about resolution. So the first question, you have this ruler in front of you, right? And the question is very simple. Can we measure 5.4 mm by this ruler? Obviously not, because this ruler is for centimeters, right? We are using it from I don't know, from starting, right? So we cannot measure 5.4 by this ruler. Why? Because this ruler resolution is not in mm, it's in centimeter. Same way, if you see the second question, I have a form here, very simple form, customer name, date received, and date issued. But I have a question for you. Can we check how many customers arrived in last 4 hours through this form? I don't have the time here. How can I say In last 4 hours, how many customers arrived? It means this form is also having a resolution problem, right? It is not having a proper resolution which is required for this kind of information. Last question. I have a very small weighing scale which mostly we use in different companies, different, maybe sometimes we are using in our house as well, right? So my question is very simple. Can we check 3 grams by this weighing scale? You will say yes. Immediately you will say yes, because this weighing scale mostly we use to weight around 1 or 2 kgs, but it is having 3 decimal. So it means we can weigh around 3 gram, 1 gram, 2 gram, 5 gram as well, right? So it means this weighing scale is having good resolution according to the information required. So indirect way, what I am saying is our gauge or our measurement system should divide at least 10 parts. What is the meaning of that? Our measurement system should have 1/10 of the resolution or discrimination. Indirect way, if you want to check, for example, in this case, if you want to check for hours, then our measurement system should have resolution of minutes. So if I want to check in last 4 hours how many people come, and if I'm checking even the minutes, I will immediately say, okay, these many people arrived in last 4 hours, right? If I'm checking some in grams, and if I have 3 decimals, so definitely I have a resolution which is 1/10 of resolution, and I can easily check, okay, whether it's a 3 gram, 2 gram, or 1 gram in right. So this is called the resolution of your measurement system. Sometimes our measurement system is not very good. For example, these two cases. So that kind of stuff is called measurement system. I have a measurement system of ruler. I have a measurement system as a checklist, but these have bad resolution. This cannot discriminate between the information what we required, okay, or what we are looking for. So that's the first part of accuracy. Next is called bias. It's a very simple thing. It is nothing but the difference between the average of observation and the target value. Let me explain you by an example. Suppose this is the weight of 5 kg. Okay, I put on the weighing scale every time 5 kg, 5 kg, 5 kg, 5 kg, 5 kg, and I'm getting these numbers. Okay, so these is not exactly 5, sometimes 5, sometimes it's having variation, right? So the overall average of these observations is called observed mean, and the target value in this case is 5. So the difference of these two is called bias. Okay. Now the second question which comes, is this bias acceptable in this example? Whatever the observation mean or observed mean is coming, and our target is 5. Is this bias acceptable? How do I check? Okay, so it also depends. Now there is a tool which is called hypothesis testing we can use to check whether this bias or this observations is okay compared to the bias or not. So how you can check? Just go to the mini tab. Let me just go to the mini tab for you guys, and I have something in the Excel file as well. Okay, let me just go to the mini tab for you. Okay, so this data, whatever I shown you, I am having this in Excel file. Let me just copy this and let me paste into the mini tab. It's opening now. So this is the mini tab. I'm using mini tab 17. You can use any other mini tab, no problem. Now I want to check whether this particular data, whatever the biases has, whether it is acceptable or not. Or indirect way I'm saying this data is having a weight of 5 kg. So, and I'm weighing something, let's say I'm weighing the vegetables, okay, and I'm a vegetable seller, and I'm weighing it, and I don't want to give less than 5 kg to my customer. Definitely I don't want to give very high amount, but compared to 5 kg, but my target is it should not be less than 5 kg. So what I will do, I will check in the hypothesis testing. Just go to stat. In the basic statistics, just go to one sample t-test. You can also watch what is one sample t-test, two sample t-test in my previous videos. Okay, but so whenever we have a data and we are comparing with a target value, then we use one sample t-test. Okay, so if you click here, just select weight, hypothesis testing. Hypothesized mean is nothing but 5 kg. So I want to check whether these weight or the observed value or the average of these weight should not be less than 5 kg, right? So what I'm checking is, it should not be less than means I'm checking, is it more than 5 kg? Correct. Hypothesized value, and click OK. When you click OK, you will have all the data or all the information here. Like, so I'm checking it should not, oh sorry, I think I've selected more than 5 kg. So let me just press Control E and change it. So I want to check whether the observed mean should not be less than 5 kg, right? Less than hypothesized mean. Click OK and OK. So let me just increase the size of session window. Now here you can see your p-value is 0.970. What is p-value and all these things? You please watch my other videos, my previous video. I have clearly explained this one sample t-test there. Okay. Now if you see, the p-value is 0.970, which says that I cannot reject the null hypothesis. I fail to reject the null hypothesis. It means my mean is equals to 5, or in other way, my alternative hypothesis says it is less than 5. So I will say no, it is not less than 5, right? It is not less than 5 because I'm going with the null hypothesis. Okay, so that is the first case. You can check your bias, whether it's an agreeable amount or not, whether it's agree or not, whether it's acceptable or not according to the t-test. And what is bias? The difference between your observed value and target value. So if I see in this case, my mean is 5.1467 and my target value is 5. So difference between these two is called bias. Okay, so this is the second type. Let's move on to the stability, which is the third part. Now stability is very simple. Suppose I am checking at a particular time frame, let's say in the first shift, I'm working in some, let's say, first shift, second shift, and third shift, and I'm checking the weight, or I'm checking the pH, or I'm checking something else through some equipment, and I'm getting this kind of process, okay, or this kind of process variations when I'm checking it the first time. Let's say I'm checking the weight, okay, and then after some time, maybe after 3 or 4 hours, the same kind of process I'm checking. This is called time 2. If there is no variation, means the mean are same. You can see this will be the mean. Let's say for this is 5, this is also 5. So if there is no variation, then I will say my data or my measurement system is stable. Okay. Now please also note that the measurement system can have a good stability time to time, but it doesn't mean that it will not have any bias. It doesn't mean that it cannot have the resolution issues. So it can have resolution issues, it can have bias, it can have stability, or it can have one more part which I'll talk in the next slide. So my point is, your measurement system can go wrong in any of these types. Okay, so in these two processes, if I see the mean both are same, so in this case there will not be any stability issue. Now how to check the stability? So the best way to check the stability is your control chart. Okay, I will also make a video on the control chart, detailed different kind of control charts we have. We have control charts for errors, we have control charts for defects, defective, and the simple variable data, subset, and there are so many. So I will create the video for that as well. But for now, how you can check the stability for these kind of data? Assume I have the data same like earlier in the Minitab. I have the data of weight, okay, and I want to check whether this data of weight is stable or not. So what I will do, I will just go to stat and just go to control chart, and there are two types are there: control chart for subgroup and control charts for individual. I will tell you in my next videos what is the difference of these, what is the difference between individual or subgroup. But for now, just remember, this data is only in like individual data points, right? So I have taken one sample at a time, not taken 5 or 6 sample at a time. So that's why it is an individual data point. So I have to use individual chart. Just go to stat, again control charts, variable charts for individual, and then you have an individual chart here. Click on this weight, and then don't change anything. There are so many things in between, like eye charts option. You can set your mean, you can set your standard deviations, You can set your limits as well, the lower and upper control limits. But for now, I'm not changing anything and click OK. So it will give me the control chart of this data. And in this control chart, I can clearly see there is an observation which is out of the control. It means the data is not stable at the observation number 8, where value is 5.9. So you can see this window number 8, 5.9, where data is not stable. Okay, so I have to go and cross verify whether there is a data entry issue or whether there is any other issue. So according to this particular data, the data or the measurement system or this particular measurement is not stable. It is having some stability issue. Okay, so that's how you can check the stability of your measurement system. So let me repeat. So you have the resolution issues. Maybe if you don't have the 1/10 of your accuracy, or indirect way your resolution. Then you have the bias issue, when you have a target value but your observations are very far. You can see the difference of these two. And then you have a stability issue, means time to time or within a particular time frame your data or your values or your observations are changing a lot. Then maybe you can have stability issues in your measurement system. And then, so as I mentioned, when we measure same part, same piece or same thing with the similar equipment by the same person but at a different time frame and getting same result, then I will say very good stability. If I'm getting different results and I'm having these variations as I checked just now, so that is called stability error in the measurement system, means measurement system is not very stable. Okay, but sometimes you can have, like in this case, in case of control charts. Okay, if I press control charts, you have only one observation, but in our case we have only few data points, I think 15 data points. Better you should have more data points to analyze. Just by one observation, I think we should not say whether measurement system is good or bad. Better you check why it is 5.9 at a particular only one data point. Okay, so you have to check, maybe somebody has wrongly entered or something has happened in the equipment at that time. Okay, so but this is how you can check whether your measurement system is working stable or not. Now the last part of accuracy is linearity. Now linearity is very interesting thing. So linearity is nothing but the variation between the measurement over the expected range. Now what is the meaning? I will try to explain you with an example. Okay, or indirect way we will say, when the measurement system has the same accuracy over the expected range. Now what exactly the meaning of this, let me explain you with an example. Okay, let me again go back to my Excel file. So there is the data of this. Now what is this data is, suppose I am checking again, let's say the weight, okay, of 2 kg, 2.5 kg, 3 kg, 3.5 kg, and it is keep on increasing. So it means it is keep on increasing in the actual part. And when I put into the weighing scale this 2 kg weight, I'm getting 2 kg, 2.5, 2.5, 3, 3. But if you see, as much you are increasing your weight, okay, you are having some kind of errors. So same times you also observe, when you have more and more data, for example in Paytm, you have more and more users, your system will start giving some errors, some issues. In SAP also, sometimes you observe we have so much of data, it will start giving some kind of errors, right? So these kind of issues, or in this case, you are putting more and more weight on the weighing scale, it is giving these kind of errors. So it start giving the variations, or your variations are increasing. Now variations means, in this case, the difference between the actual and observed. So in the starting it's look like zero, but as much as you are putting weights or you're increasing weight, your differences or your variation is increasing. So that's why you can check, there is a tool to check the linearity, which is your scatter plot or fitted line plot. And how you can check, let me show you. I just copy this and paste it into the Minitab. Let me delete the previous data whatever I have, right? And let me delete this as well. So you have actual, observed, and difference. Now I want to see whether there is a big difference between the actual and observed, and it is increasing when I am increasing my actual weights in this case. So just go to stat, and go to regression and fitted line plot. Click on this. Click. Now you have the response. The response is nothing but your differences which you are getting, and the predictor in this case you select actual, because you're putting 2 kg and you want to check how much difference you are getting when you put 2 kg, 2.5 kg, 3 kg. So that's why it is your predictors. And please also note that whenever you are using fitted line plot, your both the data should be continuous. I will also make a video on regression very soon, where I will tell you when to use regression, when to use which kind of regression, because there are many regressions like simple linear regression, quadratic equations or quadratic regression, sorry, then logit regression and so on. Okay, so you can select the graph regular, yes, you can select 4 in 1 and click OK and OK. So I think there are so many things. I've already created a video on the residuals in ANOVA. You can go through on that. Now the important thing for us to check the linearity is the fitted line plot. Okay, if you see this plot, it will tell you the exact picture, right? It will tell you in the initial part you have 4 data point at the same range like 0 0 0 0, but as soon as you are increasing, your variations are increasing, and for number 10th it is very far away. So that's why it is showing the difference also, it's increasing when you are increasing your actuals. Now by this analysis I can say for this particular equipment or for this particular weighing scale, I should freeze this for 4 kg because, or 3.5 kg, because for 3.5 kg this weighing scale is working fine. There is no linearity issue or there is no variation with respect to the actual and observed, right? And if I can have a tolerance of 0.5, I can make for this particular weighing scale the tolerance of 4 kgs. This is the last value which I can weigh in this weighing scale, because after that there are chances that it will increase the variation, right? And it will increase because after 10 it's making 1 kg of difference if I put 10 kg, which means a lot. Okay, so that kind of decision you can check for linearity. But again, this is not the solution. This is a temporary solution to say, okay, I will use this weighing scale up to 3.5. So the best way is go and ask someone to calibrate it, to check whether everything is fine, why the variation is coming. Is the variation coming at a particular part of the weighing scale, or it is coming through entire weighing scale? Maybe some particular part is having some issues. Okay, so these kind of things you can check in your accuracy part. So accuracy is having four part. One is called your resolution or discrimination issue, bias, then you have a problem of stability, and the last is the linearity. It means your measurement system is not giving the accurate result over the expected range, so then you will have the linearity issues. Okay, so this is about the accuracy part. Let me just give you a glimpse of precision. So as you know, there are two types of measurement system analysis or measurement system errors, I would say. One is because of the accuracy and the other one is precision, right? So precision is also having two parts. One is called repeatability and then reproducibility. And reproducibility is also having two parts. One is the variations comes from the operator to operator, and then sometimes variation comes from operator and part interaction. I will also tell you what exactly the meaning of operator part interaction in my next video on precision. Okay, let me just give you the rough picture of how it look like. So your total variation, this is your total variation, is always the sum of the variation coming from your measurement system, which is R&R, and the variation due to the process activity. This is the same graph which I shown you in the first slide. And then the total variation, the R&R is having two parts. One is repeatability, you can see here, precision is having two parts, and one is reproducibility. Reproducibility is having two parts because of operators and variation because of operator part interaction. Okay, so this is the total variation which we get when we study about precision. And mostly you heard about gauge R&R, which is nothing but your gauge repeatability and reproducibility. And I will definitely share with you in my next video what is the different part of or different types of gauge R&R, cross, nested and all. I hope you like